All right. On page 138, this is lesson 1 of unit 4. We did skip lesson 3. This first problem, so remember last class we talked about our inequality symbols. And the reason y'all did not pass up that other page was because you may want to refer back to it. But the main things that we learned was about the symbols. Remember that this is the less than. This one is less than, equal to. Greater than. Greater than, equal to. The other important things that we talked about was the fact that when you're graphing it, if it's a less than or greater than and not equal to, it's a hollow circle. When it's a equal to, that circle gets filled in. Today, what we're gonna learn how to do this in Desmos, and the circles it doesn't appear like this in Desmos, but if it's a hollow circle, and you may want to write this down, it makes a dotted line.
So you can use the things in Desmos?
I'm gonna show you how to do that.
Yes, I know that.
The equal to with the solid circle is a solid line in Desmos. So the difference between this and like the graphing we're doing here, is only looking at the x-axis because we're only talking about one variable. Okay, so this is all doing with one variable only. And we're gonna eventually get to where we do linear inequalities that have an x and a y. But in Desmos, they're all gonna look linear to y'all, but we can still use it for our single variable. And I'll show y'all how to do that.
What will it do for when it's equal to?
When it's equal to, it's gonna be a solid line. And you'll see, when we get to this, it'll make more sense when you see it. All right, so for our warm-up for today, all I want you to do is you're gonna put the number here that matches the symbol, the word. Then you're gonna take each of these A, B, and C, and you're trying to see if I substitute 25 where the variable is, if it's true or not. Is this one true? No. And I do that for each one. The next one, is 25 greater than 20? No. For the C one, the 30 goes first. Is 30 greater than 20? Yes. So you're going to put the numbers for the answers, and then I want you to do 3 and 4.
Huh?
Wait, but B is true.
H is.
Oh, I'm sorry. I wrote the wrong symbol. My bad.
It's a.
This was a less than equal to. That was my bad.
Oh, alright.
And that was greater than or equal to. There.
And so the top one, we write like the letter and the number in a slot on the side?
So all I did was I substituted. It said to check the value, is 25 a solution? So where the letter is, I put 25 to see if it was a solution.
No, I'm talking about where it says match up top, the number one.
Yes. Which word is that symbol?
Oh, so it's asking which word.
The
Alright.
letters name.
Yes. You're looking at which of these go with these. So which number goes in the letter boxes?
I understand that. Where are we, we're writing that in the little blank.
You're either writing a 1, 2, you're either writing 1, 2, or 3 here. Pick
Okay,
one.
That's all I need to
The
know.
one that matches.
Oh, I just wrote lines to it. That works.
All right, quiet down. You got not a minute and a half to get this done. It should not take long at all. Set a timer for 90 seconds.
We're doing 3 and 4.
Yes. good.
On number 4?
Mm-hmm. Good.
Can I get some water, Mr. Allen?
Got them all bad?
Yes.
Oh, got it.
I'm done.
All right. Y'all got about 15 seconds left.
I keep on writing slanted lines when I need a straight one.
Okay.
Thank
All right, Pax, what'd you get for A? Which one?
2.
2. H is greater than 50.
Yes, sir.
Mm-hmm.
So I'm
All
talking
right,
about
Connor, what about B?
B. I got 1.
1. H is less than or equal to 20. Good. C, Mason? It is 3. 30 is greater than or equal to H. Remember though, whenever I said we're doing these for inequalities, it helps if you put the variable first because it makes more sense. So if I flipped that around, I need to make sure it still opens the same. I take the whole thing and flip it over so that inequality symbol goes the other direction. It
And
still
why would we
opens
flip
to
it?
30.
And why would we flip it?
Because we want the variable first, it helps us whenever we go to graph. Okay? All right, so I did number 2 for you. In this one, is 40 greater than 50? No. Is 40 less than or equal to 20? No. Is 30 greater than or equal to 40?
No.
No. So none of them work. What about 30? What did y'all find? Raise your hand and tell me. What do you think, Maddox?
Because of C.
Yeah.
It works with C because
It's
30 is greater than or equal to 30. It's equal to it, right? So that's correct. Good.
Probably.
Mm-hmm.
All right, read through this real quick on your own. I'm going to give you about a minute. Read it and try to make sense of it, okay? When you're done reading, look up. That's how I know when you're ready. All right. Marco, what's it talking about?
Tell me about the ball for the seniors.
Good. So the seniors are trying to come up with a budget for the ball. I guess they call theirs a ball, we do a prom, whatever. These things that are listed here, way back when we started Unit 2, we talked about constraints. Constraints are the things that limit us, okay? So if you're talking about a budget, we could only spend a certain amount of money. That's a limitation. So let's read through the constraints on this. Last year there was 120 people. It was a success, and they think it's going to be bigger, all the way up to possibly 200 people. That's one constraint. My next constraint, there needs to be at least one chaperone for every 20 students. The next one, the ticket price cannot exceed $20 per person. Finally, the revenue from the ticket sales need to cover the cost of the meals and entertainment and also make a profit of at least $200 to be contributed to the school. So each one of these are constraints. I want to go back to this revenue. Well, we'll go back to it whenever we get to that problem. Right here, these are some inequalities the seniors wrote about the situation. Each letter stands for one quantity in our word problem situation. Determine what is meant by the letter. So I look at the first one. It says T is less than or equal to 20. What are they talking about? Raise your hand and tell me what you think T is meaning. What is T?
Ticket price.
T is the ticket price. So T is ticket price. Now, here's where we have to start kind of implementing what we did yesterday. Yesterday on that sheet, we had some key words that talked about these inequality symbols. And this one, the T, it says that the ticket price cannot exceed 20. So the way that you set up an inequality, I always write the variable and the number. The T cannot exceed 20, so it has to be less than or equal to 20. Let's look at the next one. This P, this is what we call compound inequality. It's kind of like two inequalities written together. P has to be greater than or equal to 120, but less than and equal or equal to 200. What do you think P is standing for?
People.
P is our people. So P is the number of people. And it has to be between 120 and 200.
It could be 180.
No, I see that knows up.
It's between those two.
Maybe.
All right?
Hey, what's that little dot?
Where? End. It's between 120 and 200. All right, we know what P is. P is the ticket price. T is the ticket price. P is the people. P times T. Think about-
People times the ticket.
Okay, so I asked before, what do you think revenue means?
How much they make.
How much they bring in from ticket sales. So P times T is the people times the ticket, and this is the revenue. After the revenue, we have to subtract something, an M. What do you think that they're subtracting?
What they have to give to the school?
No, it's.
Meals.
Yes, so they need to take out the meals and entertainment. So M is meals and entertainment. Remember, guys, if I'm writing it, you should be writing it, because this is what you're going to look back at when you have the problems to do by yourself. And then the reason it has greater than or equal to 200 is because we want to make a profit of at least 200. So this amount has to be greater than or equal to 200. So the profit that we need is 200. Greater than or equal to $200. All right, once you get that, let's turn the page.
Again?
Wait,
Yes.
what about the last one?
Oh, I'm sorry. Thank you.
Bro,
All right, guys, hey.
Come
Hey, well,
on.
y'all want to get to that question and be clueless?
Yes, exactly.
No.
Exactly.
All right,
Crazy.
Jackson, what do you think C stands for? Let's read back and think of what we haven't covered yet.
The chaperone.
Good. C is chaperones. So, the chaperones, there has to be more than the number of people, students, divided by 20. Think about it. Every 20, there need one chaperone, at least one for every 20 students. So the chaperone has to be greater than or equal to the P divided by 20. Does that make sense?
Yes. A
So
little bit.
this unit, this lesson specifically, is just about coming up with variables and writing inequalities to match our constraints.
Alright.
Okay? Raise your hand if you need more time here.
Do you have a problem with it?
All right, now we're going to go to the next page here and talk about an elevator constraint. So when you walk into an elevator, you see a sign that says maximum weight, right?
I've seen that.
Yes. We don't want to exceed that. Well, just to let you know, most elevators, if it says something like 1 ton, they know that there are going to be foolish people that try to overpack the elevator. So it's not necessarily going to instantly drop if you go 1 pound over, okay? Just so you know.
The elevator here is 2,500 pounds or 12 people.
Okay,
Glad you supplied me with
thank you.
How many pounds?
All right, guys, moving on. Why are we getting distracted?
How do you
Nope,
know?
stop.
That must have been-
Stop. All right, an elevator in a skyscraper can hold at most 15 boxes. That's our first constraint. For the safety, the car can carry a maximum of only 1,500 kilograms. A large box weighs 70 kilograms, a small box weighs 35, and the person riding in the elevator delivering those boxes weighs 70 kilograms. Yes.
Kilograms to pounds.
Kilograms, it's,
2.2.
so it's just a metric conversion. In other places, other countries other than the United States, they use kilograms instead of tons.
No, I was just saying.
Okay.
What it would be to pound.
Yeah, we're not,
Next.
again, guys, when y'all ask these questions that
It
are
slows you
irrelevant to what we're actually doing, you're wasting your homework time. Okay? All right, now for number 1, it says to write as many equations and inequalities as you can think of to represent these constraints in this situation. Be sure to specify the meaning of any letters that you use. So the first constraint, an elevator can hold at most 15 boxes. So let's say that B is the number of boxes. B is the number of boxes. We have to define our variables. You should be writing this. So what would our inequality be? I know that it can hold at most
Be
15
less
boxes.
than or equal to 15.
Okay, so my number of boxes has to be less than, and it can be equal to 15. That's my first inequality for my constraint.
My stress ball.
The next one, it says that the car has a maximum weight of 1,500 kilograms. So let's put W is the weight and write an inequality. It says it's a maximum of 1,500. So does that mean my weight is less than or greater than?
Less than.
Can
Or
it be
equal to.
exactly?
Yes.
Yes. Another one for boxes. We have large boxes, so L is large boxes. It's actually the number of large boxes. And let's make S the number of small boxes. I know that altogether I have 15, at most 15 boxes. So the L plus S has to be less than or equal to 15. I also need to have God bless you, a few more things left that are constraints, and that's talking about the weight of the large and the weight of the small box. So if each large box is 70 kilograms, 70 times the number of large boxes plus 35 kilograms times the number of small boxes. What else do we have riding in that elevator?
Person.
That person that weighs 70 kilograms.
Cool.
All of this has to be less than or equal to, I could either say 1,500 here, or I could say the weight. It doesn't really matter. I could have put W there, or I could have put 1,500.
If you have the person in there with them, you can only have 14 big boxes.
That's not what the constraint says.
No, it says.
It said you can only have 15 boxes, and then, but you also have to have one human, and they're the same weight.
Can I move, like,
Mm-hmm,
over there?
mm-hmm. Yeah, up to 15 boxes and a human. All right, so all we did was we looked at the situation, we wrote inequalities to make sure that we paid attention to these constraints and don't break any of the rules, okay? In number 3, an elevator, all we're doing is rewriting these inequalities so that it would work for any different building. It means we're going to a different building, okay? So instead of saying 15 boxes, let's change it to Z. So B has to be less than or equal to Z. All I did was take this one, and instead of 15, I put Z. That's it.
That's confusing.
So this is one specific skyscraper that we started with. So what they want is an inequality that'll work for any skyscraper when Z represents the number of boxes it can hold. So one skyscraper is 15, the next one may be 20, the next one may be 10, the next one might be 40. So Z is a variable representing something we still don't know, okay? Each car has a maximum of M. So this time instead of the 1,500, my weight has a maximum. It needs to be less than or equal to M. Because different buildings might have different elevators that have different maximum weights. And finally, if the person that is carrying the boxes it may not be the same delivery person at every place, so we're going to use G. So we'll have 70L plus 35S plus G, and that has to be less than or equal to that maximum weight M. So all I did was I took constraints that were specific to this one building, I rewrote the inequalities so they can go for any building. All those other buildings need to do is plug in what they know the number to be for Z and M. I know, right? Don't let this like be overcomplicated, because it's really not. It's
No,
really
just
not at all.
overstimulating.
It's just lots of words, and I know that that's the thing that scares y'all most about math is all the words.
Yeah, we use more words than we do numbers. It's the
All right,
scale from this
did
thing.
everyone get this copied down? Because y'all are about to do something that's very similar.
Yes.
Okay.
Yeah.
And in the book?
Well, after we do some practice problems. All right,
Wow.
let's go to number 1 in the practice problems. Tyler goes to the store. His budget is $125. Write an inequality, or which inequality represents X, the amount in dollars that Tyler can spend at the store. Think about it and raise your hand if you think you know the answer. Google what you think.
Oh, it has to be less than or equal to 125, so A?
A is correct.
You're so smart.
So X, guys, I don't need all of your extra comments. Just stop it. So A is correct. His amount of money spent has to be less than or equal to 125. That's simple. We're skipping number 2. Let's go to number 3.
Gosh.
Number 3.
No.
A doctor sees between 7 and 12 patients each day. On Mondays and Tuesdays, the appointment times are 15 minutes long. Wednesdays and Thursdays, they're 30 minutes long. And on Fridays, they're an hour long. The doctor works for no more than 8 hours a day. Here are some inequalities that represent the situation. Part A says, what does each variable mean? I want to know what X and Y mean. So for part A, let's look at the first one. 0.25, so Y is greater than 0.25 but less than or equal to 1. What constraint are they talking about?
Time, appointment time.
The appointment time. Okay, so Y is the length of appointment. But I have a question. It said that it was 15 minutes. Why do I see 0.25 there?
Because 15 minutes is a quarter of an hour.
Very good. 15 minutes is a quarter or a fourth of an hour.
Wait, what is APBT?
Appointment. I just didn't want to spell it out. So Y is the length of the appointment, how long that appointment took. Let's look at the next one. I have X that's between 7 and 12.
Hours
All right.
worked.
Someone else.
Hours worked.
Try reading it yourself and not giving his answer because his answer was wrong.
It means that Wait,
What is the,
Oh,
all
I know it.
right, shh,
I didn't say it.
Colin?
So he takes between 7 and 12 appointments, each day.
Okay, so X is representing the number of patients he sees.
He'll get a nighttime tiger.
All right, y'all should have this written down.
Don't put this
Without all the extra talking. I might send this video to your parents and let's see if they can pick out how often you talk out of turn.
That's a good idea.
It's a great idea.
Great idea.
Amazing. My mom would definitely watch.
All right, so now we know what X is, we know what Y is. What does the expression XY in the last inequality mean? XY has to be less than or equal to 8. What other constraint is up there that we haven't talked about yet? Mason. The amount of hours he works. So the number of patients times the length of their appointment has to be less than or equal to 8 hours because he's a doctor and doesn't want to work more. Wish I had that option. I work more and make less money. All right.
You do have it easy.
All right, go ahead and turn
But they
All
go to
the
school
way
for 11 years.
Please tell me we're on the other.
to page 149, lesson 2.
We're doing 2 lessons today?
Yes, we are.
Oh, I thought you said we
You
were.
just said
That's what we done after
It's not involved social talk.
Where are we going to?
149.
149.
That's all I heard.
All right, lesson 2. This time we're actually going to be doing some solving. So right now on your own, it shouldn't take but 30 seconds. For the warm-up, write 3 solutions to this inequality. Y is less than or equal to 9.2. Do not say a word, just write 3 answers to that inequality. And we're actually not going to do this part here.
Three.
All right, Maddox, give me one of your solutions. Okay? Y is less than or equal to 9.2. Give me a solution to that. 8. What you got, Jackson?
-13.
Negative 13. What you got, Jaden? Come on, give me a number.
6.7.
655.
All right? So there's an infinite number of solutions, and it could be any number less than, could it also be 9.2?
Yes.
Because it's equal to. All right, easy enough, yes? So a solution is something that satisfies the inequality. When I plug it in, it'll make a true statement. All right, let's look at going to apple orchards on a field trip. Doesn't that sound great?
No.
All right, well, anyway, a teacher is choosing between 2 options for a class field trip to an orchard. Orchard A, the admission is $9 per person, and they require that you have 3 chaperones. At Orchard B, it's $10 per person, but they only require 1 chaperone. The price at both of the places is the same for the adults and students, okay? What we're gonna look at for number 1, part A, I'm gonna do that one with you. Hold on, not that, that's not what I wanted. Nope, don't do that, never mind. For number 1, part A, I'm gonna see which one is cheaper for each different number of students. For the A, I know it costs $9 per person. It says we have 8 students, and we need how many chaperones?
3.
3. So all I have to do is simplify by adding the 8 plus 3, which is 11, multiply it times 9, and I get that it's $99. We're not doing the 12 student one, so if you get in that space, it's fine. Orchard B, this time it's $10 a ticket. I still have 8 students, but this time I only need 1 chaperone. Add that together, I get 10 times 9, which is $90. Which orchard is cheaper? B. I want you to do for the same thing for 30 students. So you're doing the exact same thing, but this time it's 30 students.
Can I use your calculator?
No.
Yes.
Try again.
All right, I don't need Connor answering questions for me, and Colin, I don't need you coming back with anything either.
There
Y'all have got to learn how to hold your tongues.
I answered.
How you hold it?
What do you mean?
That was him.
Yes.
No.
You're doing the same thing we just did, except this time it's 30 students.
Oh.
All right, why you turn around? Face front.
I mean, I'm gonna go get me a calculator.
Raise your hand if you need to borrow a calculator.
Oh.
I said raise your hand. I didn't say holler out. I'm definitely sending this to your parents. Let them see what kind of behavior y'all have. My goodness. Anyone else need to borrow a calculator?
I have a question.
Mm-hmm.
Where'd you get the 3 from?
Because this one needed 3 chaperones.
Oh, I see.
So it was $9. And 8 students, plus it said we needed 3 chaperones.
Right here, real funny guy. Hear that?
You're gonna do that now with 30 students, and you missed the whole second orchard. Guys, when you don't write down what I do in class, now you're lost and can't figure out the rest of it. All right, shh. First of all, you wrote the same thing. Hold on. Something wrong. This one's up a little bit because it's $10 for this one. And you did some multiplication wrong.
Did I get this right?
Okay, but guys, you have to have 2 of them. You're comparing orchard A with orchard B,
Make you check.
okay? So you want to make sure that you're comparing that. And I'm going to give more room.
Code.
Okay, but it's 30 students with the 10 come up.
Oh, right here. Oh, that's for B. Oh, shoot. I didn't see that.
Is it right?
Uh-huh.
I couldn't hear it.
I will.
Good. So which one?
Oh, this is right.
You're on the right track.
Click the freeze button.
It's moving.
All right, all right, here, the tap, nope, tap the pen. Nope, with that pen, tap this pen. Yeah, and then you can erase it.
Okay.
Is this right?
Yep.
Yes.
You
So
got.
which one's cheaper?
What do I do from
Yep,
here?
that's what it's answering.
You just straighten it out.
Good, good, so which one's cheaper?
I can go do the part B.
No.
That's all we're doing for now.
I got it right.
It's 3 chaperones per person, bro.
No,
It's 310.
total.
Are you serious?
No, you were right. Oh, this one, no, that should have been just one.
No, you're not.
Who said that, bro? I know wheelchair was on.
Good, very good.
That wasn't even in there. There's no way that's Henry is talking to me.
All right, Jay, did you engage with that?
No, man.
Okay.
I'm gonna add a little bit more water.
Yeah, this is cheaper. Awesome, thank you. Okay, so all that we had to do was in place of that 8, where we had 8, this time we used 30 students and calculated it was cheaper for, 30 students was cheaper at A. So, plugging in different numbers sometimes is difficult, and that's where variables come into play. So, to help her compare the cost of the two options, the teacher first writes this equation and then this inequality. Does this equation look familiar?
Not at all.
Yes.
Not a single lick.
Okay, so the 9, they have an n, I have an 8 and a 30.
Also 80.
They have a +3, we have a +3. What is n representing in the statement?
8.
What is n? It's a variable. It represents a number we don't know. What is it? The number of students. So n is the number of students. In this situation, if there's an equal sign in the middle, what does that tell me about the situation?
It's equal.
What's equal about it?
I mean,
So think about what we found down here. Right?
that's the total.
That's the total cost, right? So if there's an equal sign, that's going to be representing
The total.
the number of students, because n, the number of students when the cost is the same, because equal means the same, right? So if we were to try to figure out that, remember how we graphed the system of equations? We would see where they would intersect to see if that's a possibility. Look at part C. This time they put, instead of an equal sign, an inequality sign. Raise your hand and tell me, what is this answer telling us? B, it was telling us the number of students when the cost was the same. What is C telling us?
Oh, I got it. Can I say?
All right, yes.
What is the solution? Bro, what is the solution whenever B is less than A?
Okay, so wait, is this B?
Yes.
Let's look back at,
Oh, no. When
Okay.
A is less than B.
so this is orchard A, this is orchard B, and this inequality tells me when it costs less at A than B. Perfect. Now, this inequality we're going to solve to graph. I'm going to work this one with you. 9n plus 3 is less than 10n plus 1. And I don't necessarily like that they started out with some very complicated, like I would rather we started with easier equations. That's why we did that packet on Monday. So to solve, I'm going to simplify by distributing. I get 9n plus 27. Here I get 10n plus 10. Just like with variables, with equations, I want to get all my variables on one side. I want to isolate that variable and have the numbers on the other. Just like with an equation, I'm going to put a vertical line down here. I need to get my variables on the same side. I can choose to move the 10n over by subtracting. Don't write this yet. I can subtract 10n, but then I've got a negative to deal with. And I really think because of that special rule we learned Monday, remember we looked at how when you multiply or divide an inequality by a negative, it reverses the sign? Instead of having to remember that rule, let's keep that variable positive. So I'm going to subtract 9n on both sides. That leaves me 27 is less than n plus 10. Now what's happening to n? We have a positive 10. Let's subtract 10. So 17 is less than n. In order for it to make sense, I'm going to rewrite it with the variable at the left. It still opens to the same thing. So 17 less than n is the same thing as saying n is greater than 17. The reason I like to put that where you have the variable first, is so that this inequality symbol is now an arrow showing me which direction to shade on my number line. So if this is 16, this is 17, this is 18, what kind of circle do I have? Open circle, because it's not equal to, and I'm shading this direction.
We wouldn't dotted line that
Oh,
direction?
but that's what I'm about to show you about.
Wait, so if it has the equal to at the bottom, that's when you fill it in?
Correct. When it's got the equal to at the bottom, right here, if it had an equal to, that would make my circle filled in. So now I want to show you what it looks like when you do this in Desmos. Remember, Desmos is for 2 variables, but we're only using 1 variable. So it's going to look a little bit different. I'm going to take all of this and move it up out of the way so we can look at Desmos. All right, in Desmos, if I graph this one right here that we just did, okay? Do you see here how this line is dotted?
Yes.
That's the same as an open circle,
Oh.
okay? Do you see how it's still shaded to the right?
Yes.
Yes? And if I look at the x-axis, so basically, this picture is showing me x and y. Yes,
Can I get tax paper in the office to check out, please?
yes.
What?
Going golf?
Well, I'm out of here.
Okay, this is,
Hey, you going to the island?
keep it until Monday since I'm not gonna be here Friday.
Later, Liddell.
I am out of here.
Apex, you going to the island?
Guys, enough, enough. So on this, we're seeing 2 dimensions, but really we're only focused on that number line. So only the x-axis is what I'm worried about. The dotted line is what tells me that it's an open circle. And you'll see how it looks different in a minute when we get to the other problems. Are we good?
Good.
All right. Let's go to these problems. We're going to work these together. I just want you to watch for now. You will have a chance to get out your Chromebooks and put,
We're almost to homework?
we're almost to the homework, yes. We have a couple problems to do and then we're done.
With 30 minutes to get
All right, so y'all look up here. So we're on the practice problems. First thing that I wanted to make sure y'all understood how to do was to type these in. So if I'm starting to type an equation, y'all look up at the screen. If you look at your first problem in the practice problems, it starts with 7x plus 6 over 2. Start out by hitting that slash that goes across like this, right? And what that does is it creates your fraction bar here for you. Now we can type what's at the numerator, 7x, which I already have it typed in for us.
There's an easier way, I think.
Well, if you want to do it easier way, feel free to.
No.
Just make sure it's right.
No, I'm saying like to do the fraction, it's easier.
Okay, that's fine. If you know an easier way, you can do that. All right, so when I type this in like this, remember, I'm only worried about that x-axis. This is my solution. So my solution, here they're asking me in question 1, select all of the values that are solutions to the inequality. You can use Desmos by typing each one in. X equals -3. Is that part of my solution?
Yes.
Oh, yeah, yes.
How can,
Wait.
hold on,
No, it's not
stop,
a line.
stop. Raise your hand when you want to talk. Connor, why do you think that this is the part of the solution?
Because the solution is the side that's shaded and it's in the shaded side.
Correct, this is in the shaded region, it is a solution.
Go back.
All right, the next one is when x is -2. That one's kind of hard to see. It's
on.
directly on the line. Is on the line part of the solution?
Yes.
Connor, how do I know that?
Oh, wait, no.
Tell me
it's
about
not.
this line.
Because that's equal to.
How do you know it's equal to? What's different about the line
What?
compared to this one? When we did the first problem,
Oh, it's a solid line.
right, when we did the first problem, it wasn't equal to, it was a dotted line. For this problem, it's a solid line, so that means if it's directly on top of that line, it is still a solution. All right, But what I want you to be able to figure out how to do, if I try the rest of them, they're not going to be part of it. It's going to be outside of that shaded region, okay? But once you look at a graph like this and you see where it's crossing at the x-axis, you should be able to go straight to writing the simplified solved inequality. So if I type this whole thing in, I look at the graph, I always want to do the x, because that's what's our variable here. I see that it's all the numbers less than or equal to -2. Let's look at number 2 right here. I'm just going to type it in exactly as I see it. Number 2 asks which equation is correct. I see that it's crossing at the 0.5, which is the same as a half. Is it shaded less than left or greater than right?
Greater than right.
Greater than. Is my line solid or dotted? So that means there's no equal sign. So my answer for number 2 is B. Turn the page.
And again, turn it again, y'all.
Number 3. I'm going to type that in just like I see it. Unfortunately, it gives me a fraction, which I don't like the book started out. Look how hard these would be to solve, like, right?
Yeah.
So that's why we're using Desmos. On this, if you had one that looked like this, it would be a multiple choice option that would have the fraction 10/9 so that you'd be able to see which one is the correct decimal, okay? Because Desmos is going to give it to you as a decimal, but you need to know the fraction to see if it's right. So for this one, I end up getting x is less than equal to 10/9, or you could say 1.1 repeating. So if this is 0, 1, 2, my dot would be here because it's equal to, it's a solid dot, and my shading is to the left. So I want to point out one thing right here. Do y'all see how the original inequality was greater than, and it ended up less than? That tells me that at some point, if we were to solve this by hand, we would have either multiplied or divided by a negative, because that's the thing that makes the inequality reverse. And the last one, no, we have 2 more, sorry. Noah, for Noah, when you type in Noah's, this one, number 4, it's at 6. It's shaded to the right, so it's greater. Is it equal to?
No.
Because it's dotted, it's not equal to, and it's on the 6. So for my number line, I'd have a 5, a 6, a 7. I put a hollow circle, and it's shaded right. One more to look at, and then y'all will have the rest of class to do your work. 20 minutes is plenty of time. It's 5 questions. 5 questions in Desmos, literally. All right. Everybody good?
Yes.
Yep.
ma'am.
All right, the last one right here, when you type it in, it's at the positive 3.5. Remember, these are the negatives. So I know it's at the positive 3.5, and it's being shaded to the left, so it's D. All you're doing is matching that one.
Let's go. Ow, my stomach.
All right, so we are doing, you can get out your Chromebook, Desmos. I actually want each of you to get out your Chromebook and use Desmos, because I want to make sure you can figure out how to actually type it in and get the answer. Desmos is an amazing learning tool, yes. I agree wholeheartedly with you. Because this book gave us problems, there's no way we'd be able to solve those problems
No,
at
that was
this stage.
Desmos.
Like, yeah.
Now it's out our favorite.
Okay,